It's crucial to select the correct light bulbs for any electrical project to ensure safety and optimal performance. When dealing with recessed lighting fixtures like those from Hailer, it's important to adhere to the manufacturer's specifications. Using bulbs with a wattage exceeding the fixture's rating, such as using a 50-watt bulb and a fixture rated for a maximum of 35 watts, can create several potential problems. Firstly, exceeding the maximum wattage can lead to overheating of the fixture. Recessed lights are often installed within insulated ceilings, which can trap heat. Overheating can damage the fixture itself, including the socket and wiring. Secondly, the excessive heat generated by an over-wattage bulb can pose a significant fire hazard. The heat can ignite surrounding insulation or other combustible materials, leading to a potentially dangerous situation. Thirdly, using a higher wattage bulb can also damage the dimmer switch if one is installed. Dimmers are designed to handle a specific range of wattage, and exceeding this range can cause the dimmer to overheat and fail. This can result in flickering lights, a non-functional dimmer, or even a fire hazard within the dimmer switch itself. Fourthly, the light output from a higher wattage bulb may be more intense than intended, creating unwanted glare or an uncomfortable lighting environment. The purpose of a recessed light is often to provide subtle, ambient lighting, and using a bulb that is too bright can defeat this purpose. Fifthly, it's important to consider the energy efficiency of the bulbs you are using. Higher wattage bulbs consume more electricity, leading to increased energy costs. Using the correct wattage bulbs not only ensures safety and optimal performance, but also helps to conserve energy and reduce your electricity bill. When selecting light bulbs, always refer to the fixture's specifications and choose bulbs that meet or exceed these requirements. If you are unsure about the correct type of bulb to use, consult a qualified electrician or lighting specialist. They can provide expert advice and ensure that you are using the right bulbs for your specific application. Installing lights on a dimmer might seem like a solution to control the brightness of a higher wattage bulb, but this approach does not address the underlying safety concerns. While a dimmer can reduce the amount of power delivered to the bulb, the fixture itself is still exposed to the potential for overheating and damage. It's always best to use bulbs that are specifically designed for the fixture and that meet the manufacturer's wattage recommendations. Furthermore, it's important to source electrical materials and supplies from reputable vendors who can provide accurate information and support. While large home improvement stores can be convenient, their staff may not always have the expertise to provide specialized advice on electrical matters. Consulting with a local electrical supplier can often be a better option, as they typically employ knowledgeable professionals who can guide you in selecting the right products for your needs. They can also provide valuable information on safety regulations and best practices for electrical installations. Always remember to turn off the power at the circuit breaker before working on any electrical fixtures or wiring. This will help to prevent electric shock and ensure your safety. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to perform the work. They have the training and experience to handle electrical installation safely and effectively. By following these guidelines, you can ensure that your lighting projects are safe, efficient, and meet your specific needs. Always prioritize safety and seek professional advice when in doubt. In summary, avoid using bulbs with a wattage exceeding the fixture's rating due to the risk of overheating, fire hazard, dimmer switch damage, unwanted light intensity, and increased energy consumption. Always choose bulbs that meet the manufacturer's specifications and consult with qualified professionals when needed. Source electrical materials from reputable vendors and prioritize safety by turning off the power before working on any electrical fixtures. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. When selecting light bulbs, consider the following factors. Firstly, wattage. The wattage of the bulb should match the fixture's rating. Secondly, type of bulb. Choose the correct type of bulb for the fixture, such as incandescent, LED, or halogen. Thirdly, color temperature. The color temperature of the bulb affects the ambience of the room. Fourthly, lumen output. The lumen output of the bulb determines its brightness. Fifthly, energy efficiency. Look for energy efficient bulbs to save on energy costs. Sixthly, lifespan. Consider the lifespan of the bulb to reduce the frequency of replacements. Seventhly, dimmability. If you plan to use a dimmer switch, choose bulbs that are dimmable. Eighthly, size and shape. Ensure that the bulb fits properly in the fixture. Ninthly, safety certifications. Look for bulbs that have been tested and certified by safety organizations such as UL or ETL. Tenthly, brand reputation. Choose bulbs from reputable brands known for their quality and reliability. By considering these factors, you can select the right light bulbs for your specific needs and ensure a safe and efficient lighting system. Always follow the manufacturer's instructions and local electrical codes when installing and using light bulbs. If you have any questions or concerns, consult with a qualified electrician. They can provide expert advice and ensure that your lighting system is installed correctly and safely. Remember, electrical work can be dangerous, so it's always best to err on the side of caution and seek professional assistance when needed. Prioritizing safety and following best practices will help you avoid potential hazards and ensure a successful lighting project. When dealing with electrical projects, it's essential to have a solid understanding of basic electrical principles and safety procedures. Here are some key concepts to keep in mind. Firstly, voltage. Voltage is the electrical potential difference between 2 points in a circuit, measured in volts. Secondly, current. Current is the flow of electrical charge through a circuit, measured in amps. Thirdly, resistance. Resistance is the opposition to the flow of current in a circuit, measured in ohms. Fourthly, power. Power is the rate at which electrical energy is transferred, measured in watts. Fifthly, Ohm's law. Ohm's law states that voltage is equal to current multiplied by resistance. Sixthly, series circuits. In a series circuit, components are connected in a single path, and the current is the same through all components. Seventhly, parallel circuits. In a parallel circuit, components are connected in multiple paths, and the voltage is the same across all components. Eighthly, grounding. Grounding provides a safe path for fault current to flow, protecting against electric shock. Ninthly, circuit breakers. Circuit breakers are devices that automatically interrupt the flow of current in a circuit when an overload or short circuit occurs. Tenthly, electrical codes. Electrical codes are sets of regulations that ensure the safety of electrical installations. The National Electrical Code, or NEC, is a widely adopted standard in the United States. Understanding these basic electrical principles and safety procedures is crucial for working with electricity safely and effectively. Always follow local electrical codes and consult with a qualified electrician when needed. Remember, electricity can be dangerous, so it's essential to prioritize safety and take precautions to prevent electric shock and other hazards. When working with electrical wiring, it's important to use the correct gauge of wire for the circuit's amperage. Using a wire that is too small can cause overheating, insulation damage, and even a fire. The NEC provides tables that specify the ampacity, or current carrying capacity, of different wire gauges. For example, NEC Table 310.15b16 lists the ampacity of insulated conductors rated up to 600 volts. The ampacity of a wire depends on its material, insulation type, and installation method. Copper wire has a higher ampacity than aluminum wire. High temperature rated insulation allows for higher ampacities. Wires installed in conduit have a lower ampacity and wires installed in free air. When selecting wire for a circuit, it's important to consider the load that the circuit will be carrying. The load is the amount of current that the devices connected to the circuit will draw. To determine the appropriate wire gauge, calculate the total load of the circuit and then consult the NEC table to find a wire gauge with an ampacity that is equal to or greater than the load. It's always best to err on the side of caution and use a wire gauge with a higher ampacity than required. This will provide a safety margin and ensure that the wire does not overheat. In addition to wire gauge, it's also important to consider the type of insulation on the wire. The insulation protects the wire from damage and prevents short circuits. Common types of insulation include THHN, THWN, and XHHW. Each type of insulation has different temperature ratings and moisture resistance properties. Choose the type of insulation that is appropriate for the environment in which the wire will be installed. When making electrical connections, it's important to use proper techniques and materials. Use wire connectors that are rated for the size and type of wire being used. Make sure that the connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to a fire. Always wrap electrical connections with electrical tape to insulate them and prevent accidental contact. When working with electrical boxes, make sure that they are properly grounded. Grounding provides a safe path for fault current to flow, protecting against electric shock. Use grounding screws or clips to connect the grounding wire to the metal box. If the box is non-metallic, use a grounding wire to connect the equipment grounding conductors to a grounding electrode. Always follow the NEC and local electrical codes when installing electrical wiring and equipment. These codes provide detailed requirements for electrical installations and help to ensure safety. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to perform the work. They have the training and experience to handle electrical installations safely and effectively. When troubleshooting electrical problems, it's important to follow a systematic approach. Firstly, identify the problem. Determine what is not working correctly. Secondly, gather information. Collect information about the circuit, the devices connected to the circuit, and any recent changes that have been made. Thirdly, test the circuit. Use a multimeter to test for voltage, current, and resistance. Fourthly, analyze the data. Determine the cause of the problem based on the test results. Fifthly, repair the problem. Replace faulty components, repair damaged wiring, or correct any other problems that are identified. Sixthly, verify the repair. Test the circuit to ensure that the problem has been resolved. When testing electrical circuits, it's important to use proper safety precautions. Wear safety glasses and insulative gloves. Use a multimeter that is rated for the voltage being tested. Never work on live circuits unless it is absolutely necessary. If you must work on a live circuit, use extreme caution and follow all safety procedures. Always turn off the power at the circuit breaker before working on any electrical fixtures or wiring. This will help to prevent electric shock and ensure your safety. If you are not comfortable troubleshooting electrical problems, it's always best to hire a qualified electrician to perform the work. They have the training and experience to diagnose and repair electrical problems safely and effectively. Always remember that electricity can be dangerous, so it's essential to prioritize safety and take precautions to prevent electric shock and other hazards. By following these guidelines, you can work with electricity safely and effectively. When installing recessed lighting fixtures, it's important to consider the type of insulation that is present in the ceiling. If the insulation is combustible, you must use recessed fixtures that are rated for insulation contact, or IC rated. IC rated fixtures are designed to prevent the insulation from overheating and causing a fire. Non-IC rated fixtures require a minimum clearance of 3 inches from insulation. This clearance allows for air circulation and prevents the insulation from overheating. When installing recessed fixtures in an insulated ceiling, make sure that the insulation is properly installed and does not come into direct contact with the fixture unless it is IC rated. If the insulation is loose or damaged, it should be repaired or replaced before installing the fixture. It's also important to consider the type of trim that is used with recessed fixtures. The trim is the visible part of the fixture that is installed flush with the ceiling. Different types of trim are available, including baffle trim, reflector trim, and adjustable trim. Baffle trim reduces glare and provides a soft, diffuse light. Reflector trim provides a bright, focused light. Adjustable trim allows you to direct the light where it is needed. When selecting trim, consider the function of the light and the desired aesthetic. Make sure that the trim is compatible with the fixture and that it is properly installed. When wiring recessed fixtures, it's important to follow the NEC and local electrical codes. Use wire connectors that are rated for the size and type of wire being used. Make sure that the connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to a fire. Always wrap electrical connections with electrical tape to insulate them and prevent accidental contact. When installing recessed fixtures, it's important to use proper grounding techniques. Grounding provides a safe path for fault current to flow, protecting against electric shock. Use grounding screws or clips to connect the grounding wire to the metal box. If the box is non-metallic, use a grounding wire to connect the equipment grounding conductors to a grounding electrode. Always test the fixture after it has been installed to ensure that it is working properly. Use a multimeter to test for voltage, current, and resistance. If the fixture is not working correctly, troubleshoot the problem and make any necessary repairs. Always turn off the power at the circuit breaker before working on any electrical fixtures or wiring. This will help to prevent electric shock and ensure your safety. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to perform the work. They have the training and experience to handle electrical installations safely and effectively. By following these guidelines, you can install recessed lighting fixtures safely and effectively. Always prioritize safety and follow best practices to prevent electrical hazards. When working with dimmers, it's important to choose a dimmer that is compatible with the type of light bulb being used. Different types of dimmers are available, including incandescent dimmers, LED dimmers, and electronic low voltage, or ELV dimmers. Incandescent dimmers are designed for use with incandescent light bulbs. LED dimmers are designed for use with LED light bulbs. ELV dimmers are designed for use with electronic low voltage light bulbs. Using the wrong type of dimmer can cause flickering, buzzing, and premature bulb failure. It can also damage the dimmer itself. When selecting a dimmer, check the manufacturer's specifications to ensure that it is compatible with the type of light bulb being used. It's also important to consider the wattage rating of the dimmer. The wattage rating is the maximum amount of power that the dimmer can handle. Choose a dimmer with a wattage rating that is equal to or greater than the total wattage of the light bulbs being controlled. If you are controlling multiple light bulbs with a single dimmer, add up the wattage of all the bulbs to determine the total wattage. It's always best to err on the side of caution and use a dimmer with a higher wattage rating than required. This will provide a safety margin and ensure that the dimmer does not overheat. When wiring a dimmer, it's important to follow the manufacturer's instructions and the NEC. Use wire connectors that are rated for the size and type of wire being used. Make sure that the connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to a fire. Always wrap electrical connections with electrical tape to insulate them and prevent accidental contact. When installing a dimmer, it's important to use proper grounding techniques. Grounding provides a safe path for fault current to flow, protecting against electric shock. Use grounding screws or clips to connect the grounding wire to the metal box. If the box is non-metallic, use a grounding wire to connect the equipment grounding conductors to a grounding electrode. Always test the dimmer after it has been installed to ensure that it is working properly. Use a multimeter to test for voltage, current, and resistance. If the dimmer is not working correctly, troubleshoot the problem and make any necessary repairs. Always turn off the power at the circuit breaker before working on any electrical fixtures or wiring. This will help to prevent electric shock and ensure your safety. If you are not comfortable working with electricity, it's always best to hire a qualified electrician to perform the work. They have the training and experience to handle electrical installations safely and effectively. By following these guidelines, you can install dimmers safely and effectively. Always prioritize safety and follow best practices to prevent electrical hazards. When working with electrical materials, it's important to choose products that are listed by a recognized testing laboratory, such as UL or ETL. Listed products have been tested and certified to meet safety standards. Using listed products helps to ensure that the electrical system is safe and reliable. When purchasing electrical materials, look for the listing mark on the product packaging. The listing mark indicates that the product has been tested and certified by a recognized testing laboratory. Avoid using products that are not listed, as they may not meet safety standards and could pose a hazard. It's also important to choose electrical materials that are appropriate for the application. For example, use weatherproof materials for outdoor installations and fire-resistant materials for installations in fire-rated walls. Using the wrong type of materials can compromise the safety and performance of the electrical system. When storing electrical materials, keep them in a dry, safe place. Protect them from moisture, dust, and extreme temperatures. Store flammable materials, such as paint thinner and gasoline, away from electrical equipment. Always dispose of electrical materials properly. Do not throw them in the trash. Recycle them whenever possible. Many local governments have programs for recycling electrical materials. When handling electrical materials, wear appropriate personal protective equipment, such as safety glasses and gloves. This will help to protect you from injury. Always follow the manufacturer's instructions when installing and using electrical materials. This will help to ensure that the electrical system is installed correctly and safely. If you have any questions or concerns about electrical materials, consult with a qualified electrician. They can provide expert advice and help you choose the right materials for your specific needs. Always remember that electricity can be dangerous, so it's essential to prioritize safety and take precautions to prevent electric shock and other hazards. By following these guidelines, you can work with electrical materials safely and effectively.